All right, so we have this question here. It says simplify this guy, log base z of this thing. Just ignore the log for right now. So let's just simplify this thing. So I have 1 over z to the 8th to the 4th. When I'm raising an exponent to an exponent, I'm going to multiply those. So this is 1 over z to the 32nd. Now, since it's on the bottom, I can bring this to the top and make this z to the negative 32nd. So now I have this pretty much simplified. I can rewrite this. This is going to be log base z of z to the negative 32nd. I think you had the right idea. You just probably dropped the negative. So this is saying z to what power? It's kind of weird. Z to what power gives me z to the negative 32nd? So the answer here is actually just going to be negative 32, not positive. Since it's in the denominator, you have to put the negative there to show it was a denominator. Here it says solve the given equation for x. It says 5 to the x over 5 equals 5. So this is 5 to the x over 5 equals 5 to the first, right? If I have two bases equaling each other and they're raised to some different exponents, then the exponents have to be equal, right? If I have a to the fourth equals a to the x, it should be obvious that x equals 4, right? How else would it work? So when you have the same base, you can set the exponents equal to each other and solve that equation. So this is saying 5 to the x over 5 equals 5 to the first. Well, if the bases are the same, that means x over 5 has to equal 1 because this is 5 to the first. So it's just a matter of solving this equation. I'm going to multiply both sides by 5. So I get those cross out. I get x equals 1 times 5, or x equals 5. Think about it. 5 divided by 5 is 1. So that'd be 5 to the first power equals 5 to the first power. All right, here's question 8. It says solve for n in the equation below using logarithms. Round your answer to 3 decimal places. So whenever I'm solving for some variable in the exponent, I know I'm going to have to convert. And here's my conversion formula. Y equals a to the x. That's exponential. It's going to convert to this. X equals log base a of y. So I can't convert until I get the base by itself. So I have to get this base by itself. So the first thing I'm going to do is add 12. Add 12. So I get 1,059 plus 12. I get 1,071. So I get 3 times 10 to the n equals 1,071. Get the 10 by itself. Divide both sides by 3. So I get 10 to the n equals 357. Now I can convert because I have the base by itself. So now the exponent goes to its own side of the equation, n equals. The base of my exponent stays the base of my log. That's log base 10. I don't write 10 because that's the common log of 357. So I can find that in the calculator. Log, common log right there, of 357. I get 2.55. 2.553. Just like that. All right, here it says the Chinese exports of automobiles and parts is approximately follows this equation, where X is years since 1998. In what year will the exports reach 11.6 billion? Just going to set this equation equal to 11.6, 1.8208 e to the 0.3387x. Again, my unknown, the thing I'm looking for is in the exponent, so I'm going to have to convert. But I can't convert until I get this base, e, by itself. So I'll start by dividing both sides by this coefficient, 1.8208. So I get 11.6 divided by 1.8208. I get 6.37 equals e to the 0.3387x. Now I can convert. Exponent goes to its own side of the equation, 0.3387x equals log base e, which is the natural log, that's ln, of 6.37. I can find that in the calculator, ln of 6.37. So I get 0.3387x equals that, divide both sides by 0.3387. Oops, 0.3387. I get 5.467. So this is going to be x. So it's 5.467 years after 1998. So just add 5, you get 2000, sometime in 2003. Okay, don't worry about the decimal, it's just sometime in that year. They asked for the year. And the last question is use the exponential regression to find the exponential function. So we're just going to plug this data into our stat list. I'm going to go stat, enter. I'm going to put my x values into L1, 1 through 6. Just like that. And my L2, I'm going to put my 896, 924, 1088, 1230, whoops, 1230, 1474, 1634. Just like that, I'm going to go back to stat, over to my calculate menu. I'm going to go down to exponential regression, option 0. That's all good. Enter through that. So I end up getting an A value of 748.853. So we'll say f of x equals 748 point, I guess 3 decimals is good enough, 853 times 1.138 to the power of x. So that's going to go all right here. Now it says find the linear regression. It's the same thing, but now we're just going to use a different command in the calculator. Go back to stat, over to calculate. We're going to use the linear regression, option 4. Enter through all that. And we get y equals, or g of x equals 156.629 times 659.467. Whoops, that's not what I want, not times. This is a linear equation. So this is going to look like this. Y, this is going to be x, this times x plus 659.467. Okay, and the last question, I usually just go through and give you guys full credit for that. It says, which is the better model? I believe the answer is exponential. You have to graph it to see that, which we don't really cover that much in class. So you'll get full credit for that. But just knowing how to find the models is the most important part.